Hello. This is Chapter 9 for GD&T. We're going to talk more about position tolerancing and some expanded principles of position tolerancing. Symmetry and concentricity will be discussed, but really those are obsolete tolerances. I think that they can be replaced by positional tolerances. Your objectives for this chapter are explain functional gauging methods for checking hole position tolerances specified at MMC. That's the subject of your project. Number 2, specify and explain composite position tolerance specifications. Objective 3 is explain the effect of using identical datum feature references in multiple position tolerance specifications. Number 4, specify separate pattern requirements for groups of features not acting as a single pattern. And 5, specify position tolerances for inline holes. Number 6, specify tolerances to control symmetry. And number 7, control coaxial features with position or concentricity tolerances depending on the given application. And then finally our terms. So, first we like to talk about a single line position tolerance. That's essentially what we talked about in Chapter 8, just one line. When applied to multiple features, all of those features are controlled to the same tolerance. It's a fixed location, reference to the same datum frame. So if we use this same single line tolerance and we apply it to multiple features, they all use the same datum reference plane. And then composite position tolerances provide the designer more flexibility than fixed. So let's talk about composite position tolerances. In a composite position tolerance, what we have is 2 lines. Okay, the top line locates the pattern, and then once the pattern is located, the bottom line locates the features within the pattern. Okay, so we're talking about one position symbol here. We're talking about 2 different segments. And we're talking about essentially the same datums in the same order with the same modifiers. Some terms for you to know. The PLTZF, that is the Pattern Locating Tolerance Zone Framework. And that's usually the upper segment of the feature control frame, and it locates the holes relative to the datum reference frame. The tolerance value is always larger than the second segment. We'll talk about that in a minute. Okay, so once that is the pattern locating, the other one, the lower one, is typically called the feature locating tolerance zone framework. That is the lower segment of the composite position tolerance. It is not constrained in translation relative to the datum reference frame. It is constrained in rotation relative to the reference datums, and the tolerance is always a lower value than the pattern relating tolerance value. The reason why we do that is so we can control the features relative to each other better. It's like we don't really care where the pattern is, but once we're in the pattern, we tend to be a little bit tighter. We'll give some examples of that. Here is an example of a composite position application. We've got a prismatic part here. We have a composite feature control frame. The pattern locating tolerance zone framework is listed up right here. This is the 35 thousandths at MMC to A, B, and C. A being the lower surface of the part, datum B being this edge of the part, and datum C being this edge of the part. So what this says, if we're looking at just the upper segment tolerance, the pattern locating, what we're looking for here is we're looking to see that the holes meet their relative position locations with respect to datums A, B, and C. Okay, so we have a 35 thousandths tolerance zone, and that applies at MMC. Okay, so now, once we're in this tolerance zone, the lower segment, what it tries to do, it tries to hold the holes tighter in relation to each other. Okay, so when you think about like a meter that mounts in a panel, for instance. So you got this big panel that's got a bunch of different meters mounted in it. You can have a little bit more tolerance in where that meter is located, but once you locate that meter, once the pattern location of those holes is found, then you have to have a tighter tolerance to make sure that the mounting screws that hold that meter to the panel are going to be in the right position. So this is what it's saying here. We have this set of 4 holes, okay? And we're saying that the relationship of the holes to each other has to be tighter than the relationship of the four holes back to their datum reference frame. So this is how you apply a composite position tolerance. Let's talk about this a little bit more. There would be 3 conditions on this composite position tolerance. The first condition would be no repeated datum references in the second line. The next one would be 1 repeated datum reference in the second line, and the other one would be 2 datums. And let's talk about what that means to us. First of all, no repeated datum references. Your feature control frame is going to look like this. The frame locating is free to float relative to the datum reference frame, and the features must be able to meet the tolerance requirements in the first segment and the second segment. They have to meet both of them. Conceptually, this is what this means. So we don't have any datums in the second line, and so what we have is this feature relating tolerance zone framework to control only relative positions to each other, and then no rotational relationship to datums required, or features relating datums. Okay, because as you see, our datum A could be off, and it's okay. They're not related back to that datum. Now, if we repeat the primary, and I think this is more common, is we are repeating the primary datum in the second frame. So the rotational degrees of freedom constrain relative to the primary datum, and then features must be able to meet tolerance requirements in the first and second as usual. And graphically, what does this mean? Okay, so now the difference between the two is you'll see now my part is squared up to datum A now. So we still have the same pattern locating, okay, but now we have our holes restrained to datum A, and then we have our feature, our tolerance for those holes is now relative to datum A now. That is what that means. Okay, I think what I'm going to do is I'm going to stop this here, and I'm going to pick it up in a second lesson for this chapter.